Action-Based Reaction by Olivia Wolliver.
Okay, today we're going to make an acid-base reaction using our household items here. Alright, first we're going to use our baking soda to create like a little pill-shaped thing to go into our bottle. So go ahead and put just a little bit of baking soda in the middle of that paper towel. Perfect, just like that. Okay, and then we're going to roll it up right in the center there. And then I'll twist our ends. I'll fold it in. Okay, now we're going to add some vinegar to our bottle here. And then when we're done doing that, we're going to head outside and see what reaction occurs. Okay, we're going to go ahead and put our baking soda in with our vinegar and see what happens. Okay, so as you can see, mine did not explode, but you can see inside the bottle there's some fogginess, and it's definitely pent up some pressure. Oh, oh my god, are you okay? Where'd it go? There, we had an explosion. Okay, so I want to give you a little bit more information on the experiment that you just watched. And to do so, I need to give you a little bit of background. Earlier in the week, we did a lab experiment where we determined the pH level of certain substances. So the pH scale goes from 0 to 14. The lower end of the scale means that a substance is more acidic, whereas the higher end of the scale means that a substance is more basic. So a pH of 0 means that you have very, very, very high acidity, and a pH of 14 means that you would have very, very, very high basicity, and a pH of 7 is very neutral. So something like water is very neutral. This is because the pH scale, the more hydrogen ions that you have, the more acidic a substance is. The more hydroxide ions that you have, the more basic something is. So in that lab activity, we were able to determine that baking soda is a base substance, whereas vinegar is a very acidic substance. So in our experiment, we know that if you take an acid like vinegar, which we put into our water bottle, and then you start adding a base to that acid, it's going to start to neutralize. So it's going to be closer to a substance like water. And with the hydrogen ions mixing with the hydroxide ions, that's where you're getting the water from. However, with the chemical makeup of the baking soda and the vinegar, you also get carbon dioxide as a byproduct. So when we combine those two substances in the water bottle and then we added a cap or a stopper, then there was nowhere for the carbon dioxide to go. It was building up in that water bottle, building up, building up, building up, and eventually there was so much pressure inside the bottle from that carbon dioxide gas, as you heard me say when we were zooming in on the water bottle, that I thought wasn't going to explode. I said, we can definitely see that there's pent-up pressure and it's foggy, meaning that the carbon dioxide gas in the form of bubbles was apparent. So eventually we loosened the cap just enough that the carbon dioxide pressure was able to blast the cap off, and then there was so much pressure in that bottle that it shot out from my husband's hand and created like a rocket-like effect. So in short, when you mix basic baking soda with acidic vinegar, you get a byproduct of H2O, and you also get a byproduct of carbon dioxide. The H2O is from the hydrogen ions from the acid mixing with the hydroxide ions from the base, giving you H2O. Your other byproduct being carbon dioxide in this mixture in an enclosed plastic bottle is going to build up pressure until it can no longer stay inside the bottle, blasting the plug or the cap off and creating a rocket-like effect.